Okay, question 9, part C. And it's another show question. And it says, show that the derivative of 8 arc sine x plus 1 on 4 plus x plus 1 times the square root of minus x squared minus 2x plus 15 all over 2 is this square root here. Now, just a bit of a reminder where this comes from here, this back in part A, part 2, we had 16 minus x plus 1 squared, and then when we expanded, we got the minus x squared minus 2x plus 15 that's underneath that square root. All right, so I just want to point that out because I'm going to convert from that to this later in the way I'm doing it. Now, there's a few different approaches that you could do with it, but effectively they all use the same kind of ideas. So we've got to differentiate the bit on the left. And so what we've got here is, well, with arc sine, you look up your formula sheet for that to find that relationship. And so when you do that, you'll find that there's 8 times, and it's 1 over what? Well, 1 over the square root of 1 minus. Now, this angle part is, in this case, is x plus 1 on 4. All right, and that's squared underneath there. And of course, because that's more complicated than just x, we've got to use the chain rule on that and multiply it by the derivative of x plus 1 on 4, which is 1/4. So there's the first one. So we've got chain rule involved in that one. The second term here, the x plus 1 times the square root. So here we've actually got a product rule as well. So we've got a product rule here, but then we've got a square root of something. So there's chain rule involved in that. All right, so what I'm going to do is I'm going to link the x plus 1 and 2 together. So the chain rule says derivative of this times this plus derivative of that one times that one. All right, so the derivative of x plus 1 on 2 is a half, and it's a half times the square root of negative x squared minus 2x plus 15. All right, plus the derivative of that. Now, if I have that as times the x plus 1, so let's put the x plus 1 on 2 bit there, and times by the derivative of this square root. So you've got to change that into index form, power of a half, so we bring our index down and reduce it by 1. So minus a half. And then, of course, times by the derivative of what's inside here. And that's where the chain rule comes into this when we're differentiating that, which is minus 2x minus 2. All right, so there's a fair bit of stuff going on here. So let's have a look and see what we can do. So 8 times 1/4 is 2. 2 over what? All right, well, this here, 2 over the square root of 1 minus x plus 1 squared on 16 plus, all right, the square root of negative x squared minus 2x plus 15 on 2. All right, over here with all of this business over here, All right, I can take -2 out as a common factor there, x plus 1 in this one. Then I've got that x plus 1 as well, so that'll be squared over 2 2's are 4, and because that's a negative power, that comes on the bottom. Like so. All right, 2 goes in itself once and 4 there twice. All right, so next, in here, I'll leave that 2, but in here, if I create a common denominator of 16, then I get 16 minus x plus 1 squared. Plus what? Well, here, I'm going to create a common denominator with this stuff here to begin with. I'll get to that one a little bit later, once I've done some more manipulation with it. But here with these two, common denominator of 2 and the square root minus x squared minus 2x plus 15, which then means for the middle term I've got to multiply top and bottom by the square root. And when I do that, I get minus x squared minus 2x plus 15. And here, I've just got to take away x plus 1 squared. All right, so this is where I'm going to now use what I set up here. That's that relationship. All right, because what I can do then is that is 16 minus x plus 1 squared minus another x plus 1 squared all over 2 square root of 16 minus x plus 1 squared. Now, here I've now got minus x plus 1 squared minus another x plus 1 squared. So I've actually got 16 minus 2 lots of x plus 1 squared. And 2 is a common factor, 8 minus x plus 1 squared. And of course there's an over 2 there, square root of that stuff. And so they cancel. So this next line down here will become 8 minus x plus 1 squared over the square root of 16 minus x plus 1 squared. All right, now this is the left term. I've kind of forgotten all about that left term. And so square root of 16, of course, is 4, and this is like over 4, so we're dividing by a fraction here. So when you do that, you turn upside down and multiply, and we've got this 2 up the top multiplied by that 4, and so that becomes 8 over the square root of 16 minus x plus 1 squared. All right, and so that's 8 over the square root of 16 minus x plus 1 squared. We've now got a common denominator here, so we can add those together, and 8 plus 8 is 16 minus the x plus 1 squared over the square root of 16 minus x plus 1 squared, which of course this thing under the square root and this here are the same. So there's some, if we use our index laws, this is to the power of 1 and this is to the power of a half. Dividing 1 minus a half is a half, and so that's the square root of 16 minus x plus 1 squared, which of course is the square root of minus x squared minus 2x plus 15, which is what we've been asked to show. Alright, so there's a fair bit in that one there for your 2 marks. So just be very, very careful while you're doing that. Alright, which then leads us to part 2 of C. And part 2 of C is actually going to use this. So part 2, we're wanting to find this area. So the equation of the curve is the one that we got before. And so when we've got x values between 1 and 2 root 3 on minus 1. And so we're after an integral. And so if we're after an integral, that area, of course, then would be the integral from 1 to 2 minus 2 root 3 minus 1 times our root 3 on 6 square root minus x squared minus 2x plus 15 dx is what we would be after. Alright, so we've got a, well, first of all, and I'll do the rest down here, over here. And so the root 3 on 6, I can just take that out, put that outside, because that's a constant. And now I've got this square root of negative x squared minus 2x plus 15 that we've got to anti-differentiate. Now, this is where part 1 comes into it. Because in part 1, we differentiated something to get that square root. So if we've differentiated this 8 arc sine, etc., to get our square root, if we integrated our square root, go back the other way, we'd get all of this stuff. Alright, so what that then means is that this becomes root 3 on 6, that stays out there, 8 arc sine x plus 1 on 4 plus x plus 1 square root minus x squared minus 2x plus 15 on 2 between upper limit, lower limit. And so now we need to substitute, and we need to be quite careful about what we're doing here when we do substitute. Alright, so root 3 on 6 substituting 2 root 3 minus 1, so that's 8 arc sine. Alright, so 2 root 3 minus 1 plus 1 is 2 root 3 on 4, which of course that cancels, plus in that bracket it's 2 root 3, and all of this under here is the negative of 2 root 3 minus 1 squared minus 2x plus 15 all over 2. And from that we're going to subtract 8 arc sine, what is it? It's 1, so 1 plus 1 is 2, plus 2 there I am, 2, 1 plus 1 is 2, square root of 1 squared, so minus 1 squared minus 2 plus 15 all on 2, and the 2's cancel. These 2's also cancel. All right, so what do we end up with? Well, it turns out that when you simplify this one here and this one here, that they both turn out to be the same value. All right, so they actually, because we're subtracting, they actually cancel each other out. And so we're then left with root 3 on 6. Now, just as a side, it's easier to, what I've just said there, it's easier if you use the 1 minus x plus 1 squared version. All right, that works out a lot neater than what I've done here. All right, anyway, I'm starting to waffle. So 8 arc sine root 3 on 2. So here we go. Triangle pi on 3, pi on 6, root 3, 1 and 2. So root 3 on 2, there it is there, root 3 on 2. So that's 8 times pi on 3 for that. And arc sine 2/4, so that's a half. And so that's pi on 6. And don't forget that 8 that's here, that you can almost see, minus 8 times pi on 6. All right, so we got root 3 on 6, 8 pi on 3. 2 goes into there 4 times, in there 3, so that's minus 4 pi on 3. Which then means that we've got 8 pi minus 4 pi is 4 pi. That's 4 root 3 pi over 3 6s are 18. And then, of course, we've got some cancelling that can go here. 2 goes into there twice and into there 9 times. And so we finally got the answer, 2 root 3 pi on 9. All right, and then it says a root 3, the form we want is a root 3 on b. And so that's now the form that we've got. All right, so again, there's a bit of fiddling around in that. They're very easy to make some arithmetical errors, but it does use the part above to find the solution. All right, so that's the end of this paper. So, of course, you should consult your teacher, see what your teacher's view of how to do it, because there are different options for lots of these questions, and also you should refer to the examiner's report.